Okay, this is notes on 7.5 factoring trinomials. So there was a lot of information in Kurt's video. I'm going to show you some things that hopefully will make it a little easier. First of all, we have to review double distributing, but we need to understand FOIL. I know there's a lot of teachers out there who say don't use FOIL, but the reality is it helps when it comes to factoring. So I'm going to take about 5 minutes to run through double distributing, but through the eyes of foiling, okay? You might want to watch this and use a few colors. I'm using 4 different colors. It doesn't have to be 4 different colors, but it's up to you. Okay, here we go. So, looking at number 1, okay? Since we're using FOIL, it's important to recognize we have, what does it really mean? It means first times first, and that means first term times first term, okay? And that's basically getting added to the outer times outer, and that's getting added to the inner times inner, and that is getting added to the outer times, I ran out of room, but outer times outer term, okay? All right, let's stick with these colors. So what happens in number 1 when we use FOIL? Well, here's the phrase spread out, okay? And when we do first times first, it really refers to x times x. So that gives us x squared. And then we do outer times outer. That refers to the outer 2 terms. So that gives us positive 7x. Then we're going to move on to the inner times inner. And that's going to give us negative 2x. And then last times last, which will give us negative 14. Okay, now in this case, we're still not done. So FOIL helps us understand that the outer and the inner get combined. That's what happens in order to create this trinomial. So when we do that, we still have this leading term of x squared. We still have this constant or last term. It's not always a constant, but in this case it's a constant of negative 14. But the inner term becomes the combination of the outer and inner terms. And according to their signs, they create positive 5x. Okay? Now, let's try it again. First, outer, inner, last. Representing first times first, outer times outer, inner times inner, last times last. So here we go. First times first creates 6x squared. Outer times outer gives us positive 12x. Inner times inner gives us positive 7x. And last times last gives us positive 14. Again, we combine the outer and the inner to create that middle term. The front term, the leading term, stays 6x squared. The last term stays positive 14, but the inner and the outer terms, the outer plus the inner, creates that middle term of the final trinomial. And in this case, according to the signs, it creates 19, positive 19x. Okay, let's keep going. So a quote from Kurt says, to be able to do this critical skill, which is the skill we're going to get into next, you must be smart with your guesses, but patient with your checks, and patient with your checks. Um, this is something that you still will always have to do guess and check for. Okay, so let's look at this next piece. It says practice with notes, factor each of the trinomials. And my first question is, what makes one trinomial easier to factor than another trinomial? And the answer is really a trinomial with a leading coefficient. So we're going to write trinomials with leading coefficients. Leading coefficients of 1 are easier to factor. Okay, and the examples of that would be just number 1 from up above. That's x squared plus 5x minus 14. And if you look at the leading term, it has an invisible 1 as the coefficient. Another example would be x squared plus 6x plus 9. That has a leading coefficient of 1. And one more, there's many examples, but one more example is x squared minus 7x plus 12. That also has a leading coefficient of 1. So these all have that in common. They all have leading coefficients of 1, and that makes them much easier to factor. Now, if I didn't say it already, this is going on pages 124 and 125. Real quick, I'll show you. I did intend on this being 2 pages worth of notes. It's possible that I might not do the last 4 problems that I have here that are ready. We'll see how much time we use up, okay? So right now I'm still on page 124 in my notebook. Okay, so pause the video, write down what you need to write down, and we're going to move on to the next screen. All right, so practice with notes, factor each of the trinomials. We already discussed leading coefficient of 1 makes it easier, so we don't have to write that again because we've already written that down. But below that, now comes the real practice, okay? So take a look at letter A and letter B and really, really investigate the leading term of both. Which of these do you think will be more challenging and which of these will be the easier? The answer, hopefully you know, is that letter A is going to be more challenging because it has a leading coefficient greater than 1. Okay, letter B is going to be the more easier version of factoring a trinomial because it has a leading coefficient of 1. All right, so let's get into it here. So now what we're going to do is I'm going to use gray for my kind of setting up work. So my setup work that I need to do here on letter A is I need to understand that I have to factor the first term and I have to factor the last term. So what factors could create 3x squared? And the answer is luckily very simple for this one. It's just 3x times x. Okay, there are no other factors for 3. 3 is prime, so that's it. For -4, however, we have -1 times 4. That's a positive 4. We have a positive 1 times -4. And then we have one other option, which is -2 times positive 2. Once we have all this laid out with the more challenging types of trinomials, the leading coefficients greater than 1, we're ready to set up our binomial times a binomial. And we're going to have to set up what we know we can trust. So we can trust that 3x times x is definitely the first term times the first term. Oops, that's a mistake. Hold on 1 second. There we go. So 3x times x is definitely going to be the two first terms involved here. What we don't know is what the last times the last will be. Okay, so what we're going to do is we're going to check them. So let's start with -2 and +2. Okay, so I'm going to switch to a blue for this. So let's check -2 times +2. When -2, and I wouldn't write this just yet, so I have a suspicion this isn't going to work. -2 and +2. All right, now remember what I said. Remember what Kurt said. It's really a matter of just checking the O plus the I. So what I'm going to do off to the side here is I'm going to write a note that says check O plus I. And again, I'm referring to FOIL. So when the outer times the outer happens, we get 3x times +2, which is really +6x. When the inner times the inner occurs, we get -2x. When those two terms add up, so this is the outer plus the inner, unfortunately, we get +4x. Since we want +11x, this is not correct. So this is what I'm going to do. I'm going to take my pen or my pencil, and I'm going to cross out that option. Okay? Process of elimination. Now, pause the video if you need to. I'm going to move over to the space here in the middle to do my next. I'm just going to put a single line through this work, like this. I don't want to scribble it all out. I want to still be able to read it. All right, let's move over. Next attempt. Binomial times binomial. Let's try -1 times +4. Again, we know it's 3x times x. So now I'm working on -1 times +4. Okay, I'm working on that. I'm going to use green. Well, I'll use blue again, I guess. No, I'll use green again. All right, so we're trying -1 times +4. So let's put that in and try it out. And remember, we just need to check the O plus the I. So let's do outer times outer. What do we get? I'm going to need a little more room there. Outer times outer, we get +12x. Inner times inner, we get -1x. Total them up, what do we get? +11x. This is what we want, and that means that this group of binomials is the answer. Okay? All right, let's try letter B.